looking at page 55, we'll do number 2 together. So the first thing you want to do, always, list your variables. Again, you only have 2 equations that we've derived so far, but that number will increase. So, delta x, vi, vf, a, delta t. Which of these do we have? Which of these are we looking for? We have initial speed, 4.30 meters per second. We have rate of acceleration, which is given as 3.0 meters per second squared. And we have time, which is given as 5.0 seconds. So we're asked for both the final velocity and the displacement. We're going to deal with one of those at a time. So initially, let's deal with the displacement. And that'll use the equation that we just did. So initially we'll deal with displacement. Delta x equals vi delta t plus 1/2 vi delta t squared. This is the brand new shiny equation that you've got. Because we're looking for vi, we're looking for delta x, we have vi, a, and delta t. So it ties together the 4 things that we are relating. Okay, and that's really important to check for.
Is that the equation up there that we
Yeah, it is.
average?
Well, it's
the same.
yeah. In this case, we're just using acceleration. We're assuming that this is a uniform constant acceleration, and so we're getting one number for acceleration. In reality, acceleration is seldom uniform. It's a curved line, not a straight one. But we're doing one of the things we do in physics where we pretend otherwise, because it makes our math easy. Okay, so a delta t squared. Was that the puzzled look I saw on some of your faces? Okay, sorry about that. Yeah, sorry about that. Okay, so we've got our equation that ties together the 4 things that we're looking at. We're disregarding final velocity for right now. And we don't even have to rearrange. We can just plug these in. 4.30 meters per second times 5.0 seconds plus 1/2 of 3.0 meters per second squared times 5.0 seconds squared. Check it out dimensionally. Seconds will cancel. This is second squared, those will cancel. We end up in meters, which is the correct units for displacement. What raw number do you get? So we get 21.5 meters plus 0.5 times 3. So delta x of 59 meters. Okay, how many sig figs can we have? We can have 2. So that's correct. So now we do have a delta x. If we want to find final velocity, which is the next thing we're asked about, what equation can we use? So do we have an equation that ties together final and initial velocity, acceleration, and time? Yeah. Remember that acceleration equals final velocity minus initial over delta t. So we can rearrange that to say that final velocity is simply equal to a delta t plus vi. And this is really a statement of common sense. How fast you're going at the end is how fast you were going when you started, plus the amount of time you were able to accelerate at a given rate. You know, so you can think about that one that way. So let's plug in. We have 3.0 meters per second squared times 5.0 seconds plus an initial velocity of 4.30 meters per second. Our units check out. That seconds will cancel out one of those. We end up in meters per second. That's what we want. We end up with a final velocity, raw number, 19.3 meters per second. And we can have 2 sig figs, so that's going to be 19 meters per second for our final velocity. Seem reasonable, straightforward, simple? And if it doesn't, don't say yes. Physics is no place to act like you got it when you don't. If you're having problems, shout. Do you start to see how that thing works of listing your variables, looking at the things that you're relating and finding an equation that works for those? And I'll show you, after we get through the next couple derivations, I'll show you what my note card typically looks like. Okay.